the gas expansion factor, formation volume factor, and raw gas shrinkage calculators. Actually, the gas expansion factor and oil formation volume factors, these have not changed at all. The condensate shrinkage has been modified a little bit in that you have two options for building the inputs and getting a recommended shrinkage associated with the condensate inputs. This functionality was in the previous version of Toolbox, but it's been modified slightly. You go in and you can capture a condensate gas ratio, 10 to 50 barrels per million, and it's going to make a recommendation as to what should be the shrinkage that should be input into ROSE-RA or MMRA based upon those over here in the purple cells. The change here is that in the previous Toolbox was using the hexane C6 as the average cubic feet to barrels, and that's been changed to heptane based upon recommendations of the Rosen Associates engineers. But you can use the salmon cells and put in whatever is the appropriate gas liquids conversion factor for the condensate that is being investigated. The next thing that has been changed on here is an improvement and expansion of the options that are available when you know a lot of information about the gas and condensate makeup associated with a stream. Here in the previous Toolbox, you just captured a percentage of the raw gas stream that was C1 to C4. Now that's been broken out into individual products, and similarly for the non-hydrocarbon gases, there was just a single stream. So you can go in and capture those individually. In an exploration setting, generally you won't have this type of detail available. You should use the option 1, but when you have that information, it will provide to you what is the recommended shrinkage associated with the gas stream that has been modeled. Finally, there is a new worksheet that allows you to adjust a measured condensate gas ratio into what it should be in the subsurface. So for example, here the little schematic is showing the gas coming out and separating out into gas and condensate and water, and then going through another separator in here. And what this allows you to do is to capture either for produced gas or separator gas, then you can capture what is the measured at the surface, the gas versus the condensate. And if you just take a simple ratio of those two, that would be represented as, in this example, 250 barrels per million. But that is not the appropriate value that should be input into MMRA, because this is already a shrunk volume, and what you need to input into MMRA or ROSE-RA is the original raw gas stream. And so what this does, based upon your inputs and a captured API gravity or molecular weight, then it will suggest and that the raw gas, when this condensate 2,500 barrels is put back and converted in the reservoir into gas, then there would have been over 12 million cubic feet per day. And when you divide that 12 million by the the 2,500 barrels of condensate, the value that should be input into the prospect analysis software is 200 instead of the simple division of 250. If you use this 250, then you're going to overstate the amount of condensate that would be derived from the raw gas stream. So an important tool to help you to be able to represent the gas stream, raw gas stream versus the separator stream, the sales gas stream appropriately.